Okay, so for the following circuits here, following circuit here, we have to solve for VO. So we're told that V1 is 1 volt, so we'll replace that with 1 volt, and V2 is 2 volts. Okay, and these are ideal op amps, so the current here and here, and here and here will be 0, and same with the current here and here. And and it also means that the voltage here and here should be the same for this op amp. The voltage here and here will be the same for this op amp, and the voltage here and here will be the same for this op amp. And we see they're all connected to the ground. So the ground, it has a 0 volt here, so that means the voltage here will be 0. Same with here, and same with here. Okay? Now, we can pretty much find, as pretty much we see the current, uh, sorry, okay, let me rephrase this. The current passing through here will be the same as the current passing through here. Okay? Because since the current here is 0, we can just ignore this. And the same goes for this one. And the same goes for this one. The current entering here will be the same as the current here. So let's call this I1. Let's call this I2. And let's call this I3. Okay? So let's solve for I1. I1 will be equal to 1 minus 0 all over 2000, which gives me 5 times 10 to the minus 4 amps. For I2, it will be 2 minus 0 all over 4000, which will give me 5 times 10 to the minus 4 amps again. And we can use that information to find the voltage at this region, because since we know the voltage is here, this minus this all over this should equal to this. So let's do the first part. So 0, 0 minus, let's call this VA. 0 minus VA all over 6000 will be equal to 5 times 10 to the minus 4, which is I1. And that makes VA equal to minus 3 volts. And same goes for this one. 0 minus VB, this one will be VB, all over 8000 will be equal to 5 times 10 to the minus 4. And that gives me VB will be equal to minus 4. Okay? So this is equal to minus 2. This is, sorry, minus 3. This is equal to minus 4. Okay? Now, we need to find the current passing through here. Okay? The current passing through here will not be the same as the current passing through here, because there's also current passing through here and here. And obviously, it's going to be a little difficult to determine that value. But we know that the voltage for this entire region will be 0 volts. So let's call this one IA, and let's call this one IB. So IA, the current formula for IA will be VA minus 0. So VA minus 0 all over 5000 ohms. So VA, recall it's minus 3. So it'll be minus 3 divided by 5000. And this will be your current value. And then IB, it'll be minus 4 minus 0 all over 15,000 ohms. And that gives you minus 2.6667 times 10 to the minus 4 amps. Okay? They enter here, and we see I3 will be pretty much this current. So IA plus IB should be equal to I3. IA and IB are entering this node, and IB is leaving. So sorry, IA and IB are entering this node, and I3 is leaving. So I3 will be minus 6 times 10 to the minus 4 plus minus 2.6667 times 10 to the minus 4. And let's see what that gives me. And that gives me a value of minus 8.6667 times 10 to the minus 4. And now we can solve for VO. So VO will be this point. So this will be VO here. So it will be 0 minus VO all over 10,000 equals minus 8.6667 times 10 to the minus 4. And we can now solve for VO. And we get a value of 8.6667 volts. And this is your final answer.